Okay, section 2, you're going to be given a lot of information. Some of it will be useful second semester. Some of it is just random facts and trivia, but you will not be assessed over all of the information in section 2, okay? We're going to talk about a couple of segments we've never talked about before. Okay, the first one is an altitude. And if you think about like the altitude of an airplane, we measure from the airplane straight down to the ground, and that distance is perpendicular, okay, which is what the altitude is, okay? It goes from one vertex of a triangle, and it is perpendicular to that opposite side, okay? The second segment we're going to talk about that we haven't yet is the median, okay? And a median, its endpoints are a vertex of a triangle, okay? So like point C here, and the midpoint of the opposite side. Okay, D is the midpoint of AB, which is opposite that vertex C. Okay, so CD in this picture is a median. All right. Points of concurrency will not be assessed over, but there are some fun and interesting little tidbits about each of these that we're going to talk about. Okay, and first we are going to define the word concurrent. Okay, concurrent is a way to describe lines that all intersect at one point. All right, so point P is the point where all three of these lines here, lines A, B, and C, intersect. So point P is the point of concurrency. Okay. Now we talked about perpendicular bisectors and angle bisectors in chapter 1 and a little bit throughout the other chapters. Okay. When all three perpendicular bisectors of a triangle intersect, that point is called the circumcenter. Okay, the circumcenter is equidistant or the same distance from all three vertices of a triangle. Okay. Angle bisectors, if we put all three of those in a triangle, that point of concurrency is called the incenter. Okay, and the incenter, that singular point, is equidistant from the sides. All right, when all three altitudes intersect, we call that point of concurrency the orthocenter. And then when all three medians intersect, that point is called the centroid. Okay, and the centroid, we'll do a short little activity in class. The centroid is actually the center of gravity of a triangle, which is kind of cool. Okay, but we are going to talk about the centroid a little more. Okay, and the centroid, that point where all three medians intersect, like here, point P, okay, is 2/3 the distance from the vertex to the midpoint of the opposite side. Okay, so if we take, for instance, just the segment, we're looking at this median KT here. Okay, KP is 2/3 of that distance from K, from the vertex, all the way to T. Okay, which also means that PT, okay, from the centroid to the midpoint, is 1/3 of the total distance from vertex to midpoint. Okay, we'll look at a second median. Okay, if we look at the distance from J to S, okay, from vertex to midpoint, JP, so from vertex to centroid, is 2/3 of that total distance of that entire median. Okay, which means that from centroid to midpoint is 1/3 of that total distance. Okay, and then let's look at R is the midpoint, L is the vertex. Okay, so that distance from the vertex to the centroid, from L to P, is 2/3 of that total distance from L to R. And then centroid to midpoint is 1/3 of that total distance. Okay, so putting that into action a little bit here. Okay, let's look at this first example here, okay? In Q, so this entire median here, from vertex to midpoint is 6. Okay, RK is 3 and PK is 4. We're going to find the segment of each, the measure of each segment that is listed below. Okay, so the first thing I like to do, let's look at here, we know that from P to K is 4. Okay, that's from vertex to centroid. PK is 2/3 of that total distance from from P to M. Okay. So from P to K, that is 2/3 of the entire distance from P to M. Okay. So since PK is 4, we're going to multiply 4 by 3/2, which means that from all the way from P to M is going to be 6. Okay, which is one of our segments here that we're trying to find. Okay, and if P to M is 6 and P to K is 4, that means K to M is 2. Okay, now K to Q is that next one we're trying to find. Okay, now we already know that from Q to N is 6. Okay, so Q to N is our whole segment. K to Q is 2/3 of that whole line segment QN. Okay, so 2/3 of 6 means that K to Q is 4. Okay, and then if all of that is 6, but we've already used 4, N to K is 2. Okay, and then those last couple of segments here, if R to K is 3, okay, again, that's vertex to centroid. That distance is 2/3 of the entire median, R all the way to L. Okay, so if we know that R to K is 3, and 3 is 2/3 of something, okay, multiply by 3/2 gets us that L to R is 4.5. Okay, and if this whole line segment from L to R is 4.5, All right, K to L then, there's just 1.5 units left. Okay. Now I know this is tricky. Okay. I want you to try example number 2 on your own. If you don't get it, we will definitely be going over this in class, but also take a little bit of a breather. You are not going to be assessed over this centroid distance stuff. Okay. You might pay attention to up here. If we focus on just Q to N, okay, that whole portion is 6. The bigger portion, okay, from Q to K, or from the vertex to the centroid, is twice as long as it is from centroid to midpoint. Okay, or from midpoint to centroid is half as long as it is from centroid to vertex. Okay, so keep that in mind as you try number 2 on your own. Okay, but now we're going to talk about midsegments. Okay, and a midsegment of a triangle has to do with midpoints again, but instead of being from a vertex to a midpoint, okay, the midsegment, its endpoints are midpoints of 2 sides of the triangle. Okay, and the midsegment, so down here, J is a midpoint, K is a midpoint. The midsegment is parallel to the third side. All right, so JK here is parallel to FG. Okay, but it is also half the length of the third side. Okay, so JK is half the length of FG in this picture. Okay, another way to think about it is the third side, so FG here, is it takes 2 midsegments to get to the length of that third side. Okay, so here, if XZ and XY are midsegments, we want to find the length here first of XZ. Okay. Here, XZ does not intersect RT here. Okay, so those are the 2 segments we're going to focus on first. And remember, the midsegment is half of the third side. Okay, so XZ is going to be half of 13. So XZ is 6.5. Okay. Here, we know XY is a midsegment. Okay, so that side that it does not touch, it's not only is it parallel to it, okay, but the midsegment is half of the third side. So 7 is half of what? 7 is half of 14. Okay, so ST is 14. All right, now I'm going to erase these line segments that I made because we're talking about some angles now. Okay, we want to know the measure of angle RYX. Okay, RYX is this angle that's right here. Okay, one thing that I think will continue to come back in this class is going to be when lines are parallel. I want you to think of alternate interior angles. Okay, so if we look at this set of parallel lines with this transversal, angle RYX and YXZ here are alternate interior angles, which means they are congruent. So RYX is 124 degrees also. Okay. Number 2 we're going to talk about together. All right, so knowing here that F and E and D, those are all midpoints. That means EF is a midsegment. Okay, that we're going to relate to AB. Okay, and ED is also a midsegment that we're going to relate to AC. Okay, so part A here, we want to know the length of DE. Okay, DE is a midsegment and it is half of the third side that it does not touch. Yikes, 15. I need to erase this random line that showed up. Okay. 15 divided by 2, because we want half of it, is 7.5. So that is the length of DE. Okay. DB is part of the whole line segment AB. Okay, so if we know that FE is half of this whole line segment, okay, and we only want half of that line segment, that means DB is also 9.2. Okay, now we're talking about an angle again. So if we look at angle FED, okay, FED right here, okay, FE is a midsegment, AB is that third side that it does not intersect, so these are parallel. Okay, if DE is that transversal, these two angles are my alternate interior angles, so the measure of that angle is also 82 degrees. Okay, now I want you to do example number 3 on your own. Okay, and then you can check your work in the completed notes.